All right, welcome to worksheet number 3, the precise definition of a limit. This corresponds to section 1.7 from our textbook. Here we're going to revisit kind of like the first worksheet when we talked about definition of a limit. So here we're going to look at it in more detail. What does it really mean to say that limit of f of x as x approaches a is equal to L? That means x is approaching to a, and then f of x is approaching to L, right? So when x is approaching to a, basically x is near a. And when f of x is approaching to L, f of x is near or close to L, right? So here we'll talk about like how do you precisely define something is close to something or something is near something, right? What we're going to do is we're going to use a concept of absolute value to decide two numbers are close to each other or two numbers are near. So generally speaking, like absolute value of a minus b represents the distance between a and b. So if I have two numbers a and b, how do you represent the distance between those two numbers? I can do absolute value of a minus b. We can basically do either b minus a or a minus b, depends on which number is bigger. But the easier way to saying is absolute value of that. So we'll use that as distance between these two numbers. From there, we can say when two numbers are near each other or two numbers are close to each other, basically the absolute value of their distance is very small. Means absolute value between those two numbers are very small. Same, if f of x is close to L, that means the distance between f of x and L are very small. That means the absolute value of f of x minus L is very small. So that's what this definition kind of says. If for every real number epsilon, this number, the Greek letter epsilon, there's a number delta. So again, this is Greek letter delta. Epsilon is basically E in English. It's a Greek letter. And delta is basically D in English. So we're just using different like alphabet. Such that if absolute is 0 is bigger than less than absolute value of x minus a is less than delta. Wow, what does that mean? So if you look at here, I have absolute value of x minus a. So that's basically distance between a and x. So distance between x and a. What it says is if that's less than delta, so if delta is a small number, that means distance between x and a are a small number. That means x is approaching to a. So this is just a different way of saying x is approaching a. What they're saying is x minus a is less than some small number delta. Then you can another kind of similar format. I see absolute value of f of x minus L. So again, what does that mean? That means distance between f of x and L is again less than some number epsilon. So if epsilon is a small number, that means the distance between f of x and L is a very small number. That means f of x is approaching to L, right? So this is just a different way of saying f of x is approaching to L. That means L is the limit, right? Then we can say the limit of f of x as x approaches a. So x approaches a is represented this way. And the limit is equal to L is represented by this way, right? So in practice, what's going to happen is they're going to give us epsilon. And basically, we have to find the delta such that this thing happens, right? For our class, we're going to deal with it in terms of graph more than actual like a function. So here's L, that's the limit. Here's A, right? L is here. F of x minus L is less than epsilon means distance between L and f of x is less than epsilon. So this distance is epsilon here. This distance is epsilon here. So it could be a little bit bigger than L or a little bit smaller than L, right? So it's L minus epsilon, L plus epsilon. So y value has to be somewhere here. So if your y value is somewhere here, that means you're close to the L value, right? And then if you look at here, A is your, again, A plus delta, A minus delta. That means x value is close to a. So That means if you pick any x value from any x value from here, that means what your y value is going to be closer to L in certain ways, right? It's not going to be too far from L. So if I can find such delta, then you're kind of guaranteed that your function, y value of your function is very close to L. So as long as you pick your points here, your y value is going to be closer to L, right? Because that's what you want as the limit. So let's look at some examples with actual numbers in it. So let's look at example 1. So consider limit of f of x as x goes 3 is equal to 5. The question is, for each value of delta epsilon, determine the value of delta. So this is delta is what number we want to find, such that the absolute value of f of x minus 5 is epsilon whenever x minus 3, the absolute value of that is less than delta. All right. So let's look at the example here. Sorry, there's a lot of space here. So case where epsilon is equal to 1. So if I were to rewrite it, I want f of x minus 5 is less than 1 for delta such that x minus 3 is less than delta. So the question is, what delta should I pick? Let's zoom out a little bit. Let's look at the picture here. F of x minus 5 is less than 1. So limit is 5. Again, this is my y values. So 5 is here, right? That's my y value. F of x minus 5 is less than 1 means distance between f of x and 5 is less than 1. That means it could be as high as 6 or it could be as low as 4. So let's use red marker to here. 5 is my limit L. So it could be 1 higher than 5 or 1 lower than 5, which is 4. So that's epsilon is equal to 1, right? So epsilon is given to you. They're saying you need to be close to 5. Like, what do you mean by close to 5? By 1. So no more than 6 or no less than 4. So somewhere between 4 and 6, right? So what I'll do is I'll kind of dotted line here is right here, and then dotted line at 4. So right like here. That means I don't want to pick points from here, because if I pick points from here, that's like 6.5 whatever, or 7 even. That means it's too far from 5, right? So I want to make sure my points gets picked between here, this area, right? So let's look at the corresponding x values. So what x values do I need to pick to get that? So over here, my x value is 1. Over here, my x value is 5, right? So what that means is if I pick my x value to be 6, then f of x is not going to be close to 5. Again, if I pick my x value to be 0.5, then my f of x value is not going to be close to 5. But if I pick my x value to be like 2, then my y value is going to be close to 5 because it's 4.5, right? So as long as you pick your x values here, you'll be closer to 5. You'll be close to 5. So my a is 3. So what's the distance? How far can I go? Like 5, right? So that's 2 steps, 2, and then 2. So as long as your x value is within 2 distance from 3, you can pick any points in there, right? So here what I can say is, as long as x minus 3 is less than 2, then f of x minus 5 will be less than 1, right? 2 here is a magic number. All right, part B. Here I'm going to have you guys try. Part B says epsilon is 0.5. So just to set up, that means that distance between f of x minus 5. So distance between f of x and 5 is less than 0.5. That's my hint. So I'll have you finish part B, and basically in this section, this is all we're going to do. We're going to do the other ones we're going to skip. So for this section, we're just going to, you just have to know how to find delta according to the graph. Okay.